All right, so welcome everybody. What I'm going to talk today is a little bit about Lambdas and Raspberry Pi. These are both extremely relevant. Jim's already covered Lambdas a bit. These are extremely relevant for the Java 8 release because this is the first release, well, of course, first release with Lambdas. That's been, anybody been waiting for Lambdas a little bit? Yeah, this is probably one of the most anticipated language features in a while, and I'm glad that the team with Brian and all the other guys did a really good job getting it right, even though it took a while to come out. And also, it's the first release of JavaFX on ARM. So there's Java SE on ARM. You guys might not have heard, but at Java 1, we announced that the Raspberry Pi Foundation is going to start shipping Java with the Raspberry Pi images. So if you download the official images of Debian or Noobs from the Raspberry Pi site, you'll now get Java Embedded 7. But what we're going to use today is the Java 8 early access because that has all of the JavaFX capabilities. You can do the same thing you're doing on desktop on the Raspberry Pi. So these are some of the enhancements in the Java 8 release. And there's a whole bunch of things other than Lambdas, but probably the most significant one from a language perspective is the new Lambdas support and the API changes which go along with it. And really, it was a coordinated platform upgrade. You got Java 8 Lambdas, you got a whole bunch of new APIs which go along with it, like the streaming APIs and the date and time APIs, taking advantage of the new Lambdas feature. And I think what you're going to see in the future is that a lot of frameworks and Java libraries and even third-party projects are going to start adopting Lambdas as a better way to write syntax, do reactive programming, do a lot of things which were typically associated with third-party JVM languages on Java instead of doing it in another JVM language. So it's really exciting for language and framework designers. So let's see how awake you guys are after the break. Who codes using NetBeans? All right, quite a few folks. And have you guys tried the new Lambda support in NetBeans? Latest builds with Lambda support? Yeah, some? So I've heard that there's a cool feature. I actually haven't tested it myself, but I've heard there's a cool feature where it will actually convert your code automatically, and wherever it's possible, we'll use Lambdas instead of the older patterns for inner classes. Okay, and then any IntelliJ users? Okay, quite a few of those as well. IntelliJ is quite cool. I'm actually going to use IntelliJ for part of the presentation here, and they have really good Lambda support, and their new JavaFX support is really nice as well. So that's another good IDE. And any Eclipse users? Last. Okay, so I think that covers everyone in the audience. I believe, I haven't tried Lambdas in Eclipse, but I believe it's not quite as far along with Lambda support in Eclipse. Anyone confirm, yay, nay? You guys tried it? Okay, so I think that confirms it's not quite as far along. But it will get there as well because this is basically the next big language syntax. And I forgot one IDE. Any J developer users in the audience? Okay, well, later on, you can after the presentation, you can come and tell me on the side. Don't bother raising your hand. Feel free to the same ground rules as Jim. Interrupt me, ask questions. I believe there's microphones on the side, or you can just shout out. I won't actually see your hand because of the bright lights in my face, but just shout out and say, "Hey, Steve," and I'll answer your question just like the other gentleman who had a question about native Windows. We mostly figured out the answer, but we're going to see if we can get a better hack from Rich later. Okay, so this is how you would write a simple loop in Java 7, iterating through a list of shapes and then changing the color. This is how you would write the code using the new Lambdas API. So Jim went over the basic syntax, but you can tell it's a Lambda by the beautiful arrow, or the : if you're using method references. And it gives you a nice, convenient syntax. There's not a lot of difference between these two because the former was kind of an improvement in Java 7 syntactically, but there's a whole lot of things where if you had the latter, you wouldn't develop a new language syntax just for that use case. You'd prefer doing it using a Lambda where you could pass behavior right into the expression. And the way which they added this behavior to the libraries, the new for each method on collections, is they took advantage of a new feature called extension methods. So prior to extension methods, if you add a new method to an interface, what typically happens to all of your library users? Or folks who implement the interface, are they happy? Probably not very happy. They probably have backwards incompatible code because they have unimplemented methods and their code won't even compile anymore. Default methods are a very nice feature which lets you provide a default implementation on the interface. So you can actually add new functionality to interfaces without breaking backwards compatibility, which was extremely important for the Lambdas change because they were making a bunch of API changes all throughout the code. To add new methods like for each, add the streaming APIs, and in general take advantage of Lambdas in different parts of the Java libraries. So they were deprecating some of the older ways of doing things and introducing new Lambdas patterns for doing the same thing. And this is the basic Lambda syntax in a slide. So the long form at the top, that's declaring types and putting your statement inside of brackets. And then it'll automatically type inference, as Jim mentioned, so you can actually leave the types off. And if you're simply returning a single method line, you can actually leave that off. And you get simpler and simpler. If you have no parameters, you need the parentheses at the left side. I think the Java team lovingly calls that the hamburger operator. And then you can also just execute a single statement, which is very common if, for example, you are implementing a runnable and trying to replace that with a Lambda instead, which automatically happens. So basically, any interface with a single method automatically becomes a functional interface. So that means existing methods like, runnable and all the Java event classes, they all automatically become functional interfaces. But there's also an annotation you can add, which is called @functional interface, that you can annotate your classes to be a little bit more declarative about this. And the way I would equate this is this is kind of analogous to if you look at the override annotation on methods. So they introduced the override annotation, and it's a good pattern to use because if you put the override method, then it will throw a compiler error if you're in fact not overriding a method. So if you think that you're overriding a method and you're in fact creating a new method, or you got the syntax wrong, or the parameters or something, then it will give you a compiler warning or a compiler error to tell you that you actually messed up. But you don't have to declare that you're overriding a method. It's optional. And the functional interface is similar. If you declare something as a functional interface and it breaks the pattern by having multiple methods or in some subtle way can't actually be used as a functional interface, it will throw a compiler error and give you some feedback that you have incorrectly specified a functional interface. But it's not actually required. If you have an existing library or you have stuff which simply declares interfaces with one method, then you can take advantage of Lambdas and functional interfaces without actually going back and annotating all of your code. So something handy to use if you're going back and updating your code for Lambdas, kind of like what the Java team did when they went through all the class libraries and tried to update stuff for the Java 8 release. So I'm gonna show you guys a really simple application, and this is a little JavaFX app that I wrote. Actually, I use it for testing a bunch of the JVM language ports, which I've worked on the side, and it's nice because it's a short enough program that you can you can get a feel for the different features of JavaFX and how they translate to Lambdas. So let me run the application first and then show you visually what's happening on screen. So we've got a bunch of circles, and they're moving around, and they got, like, you know, they're transparent, so they kind of blend together. And then when we mouse over, it highlights. It's actually changing the stroke width. So previously the stroke width was 0. Now it's creating a stroke width so we can see the border. And so whatever you're highlighting will get a little, whatever your mouse is over will get a little border to highlight it. And finally, we have an event handler that we click on this, and it, you know, vanishes with a nice JavaFX animation. And this whole code fits on a couple slides. So let's walk through it and see if we can improve on my my crufty old Java 7 code. And this is the part where you guys shout out random things at me, and hopefully you're not too much smarter than me. You don't embarrass me. Okay, so here's the application skeleton. Vanishing circles, extends application, has a main method, has a start, and then I put some random logic in it, and I have little red blocks there for where the subcode goes for creating the circles and starting the animation. Now I couldn't find anything in this code which got significantly better in Java 8 because it's mostly boilerplate. But well, actually, this is a Jim question. I'm going to bug you, Jim. I remember them talking about, like, doing something more efficient with JavaFX launching in Java 8, where the main method wouldn't be called anymore, required. So do you know?
It's not called.
Okay, it's not called, but is it?
Right, runtime. The only time it would be required is if you were calling it.
So can I actually cut that out of my Java 8 application and still be happy?
Right, if it launches, yeah.
Okay. It's just a fallback. Yeah, okay. So we found one thing on this slide we can improve slightly. We can get rid of that main method. It's probably good to have it there anyway as a fallback, but we could trim that off in Java 8. Not really a Lambda's improvement, but okay. Thanks, co-presenter team, for on-the-fly updating on the latest Java 8 status. For creating the circles, we go through a little loop, and then we iterate over a fixed size of 50, and then create the circles and add them to the list. Anything here look like it can be improved? Yeah. No, possibly. So, you know, usually when you see a for loop, you're like, oh, well, we could do that with a Lambda, and we could, you know, iterate over a collection or something. It turns out that doing fixed loop, I had this discussion with Brian Getz on another application I was doing. It turns out doing fixed loop iteration is not really a great use case for Lambdas. So if you really wanted to do it, it would look like this. So basically, you can use the streams.generate function, which is part of the new Streams API I'm going to talk a little bit more about in a sec. And then you have a Lambda, which actually has your generation function inside of it. So this generates your circles in the list and returns them. And then you can go through that list, and the first thing, generates an infinite series. So you have to use limit or subsequence to limit the number of items down. So that gets you 50 elements, kind of like a fixed iteration of 50. And then you can return it as a list there using the collectors, the reduce and the collectors to list. So you can do it, but I would probably say the fixed iteration loop is preferable to the generation case if you're actually doing fixed iteration. So that's probably not something we want to fix. Binding as well, this is a pretty new API in JavaFX. I don't think there's anything particularly enhanceable in here. How about this one? This is the event listener, so when you click on the circle, it animates it disappearing. Okay, so I see people nodding. I think that's a sign that, yes, we should replace this with an event listener, or a lambda-ized event listener. This is actually the most common use case for JavaFX apps. You can replace this everywhere in your JavaFX code for callbacks. And then here's another example of a loop where we're looping through the circles, and then we're doing the initial animation, setting them up so they slowly glide around the screen. Any recommendations here? Okay, so this one, again, we can do a little for each, and this actually is a really good example of for each. It fits the syntax nicely, and it lets us iterate over an existing sequence of objects and apply an operation to them. And if we were really cool, we could do this in parallel on multiple threads, but the reality is you don't want to do that in your JavaFX application because you're gonna break your event threading. Okay, so we're gonna take a little example. This is a retro game which I wrote with. It does not in any way stress the graphics capabilities of JavaFX. So don't assume that don't assume that JavaFX can only do 8-bit graphics. But it's a nice example of some of the Lambda's APIs as both a JavaFX application which is written using the latest Lambda's patterns, and also an application where the gaming semantics are designed around the stream APIs to show some of the stream concepts. So, generating streams. Let me show you a little bit of streams. Let me show you a little bit of the code first, and then we'll dive back in. Okay, so basically that's my egregiously large presentation font. I don't actually code with fonts this large. This whole application is 3 files. So there's a main file. This is the one we'll be editing. It's the main JavaFX application class. It just populates the objects on the scene up here. So we have add objects to the scene graph. Populates a background with an image, and then draws little borders around the cells. So this is pretty straightforward. Yeah, and here, just for kicks, I have a standard iteration loop, and then I have what if you wanted to use it using lambdas. And it turns out the fixed iteration is actually nicer, so you can do it either way, but use the fixed iteration. Yeah, some key handlers. And the whole file is, it's like under 200 lines of code for the main class. And there's a little sprite view class which does the animation. So basically, I'm taking sprites that look like this. So little RPG style sprites where you go left and right for walking animation, and then up and down for the different angles. And a sprite view class, which it actually animates that simply by moving around the clip or the viewport. So it simply moves the viewport rectangle around those different frames, but then uses the image as a sprite. So that whole animation class is about 261 lines of code. And the main class we'll be sitting in is a map object class, where it defines different objects. And each of the objects, the basic pattern is it loads an image. So it's loading the graphic as one of those 12 size sprites. And then it has a visit method where we're getting called back whenever we step on top of it, and we can execute some action on there. So let's give it a try and do some object generation. So we'll just leave in the barn and take out these guys. Okay, so we got our little character and our RPG walk, the very finest graphics. And when we step on the barn, voila, we have lambdas. All right, so now if we actually look at the code for this, there's a bunch of ways you can generate streams. So this is an example of how you generate streams. I showed the generate method earlier. That one simply takes a constructor and calls the constructor to generate a sequence of objects. You can also take any collection and get back a a stream directly from the collection. There's a static stream.of, which will give a list of objects or numeric or other types, and it will return back a stream of that type. And an inStream.range, which gives you back a numeric sequence of numbers, which you can then do operations on. And then finally, there's generate and iterate, which are probably the most common ways you're gonna see, other than the first one, getting from collection. Generate and iterate are really good ways to get streams. And in this case, so the example here iterates over the color, starting color, and then each time through the loop, it's doing a Lambda expression which gets the previous color as the seed value, then modifies the hue by adding 0.1 to it, so it's going to give a slightly color shifted, and then returns back a new color, and the next color would be 0.2, and then 0.3, and 0.4, so you get a nice rainbow hue generated programmatically using the Lambda's iterate function. And the same thing applies for how we're adding sheep to the scene graph here. So we get the last animal using the standard kind of give me the last item in a collection, and then iterates through all of the objects we want to create to add additional animals. So we start with Mary as the tail. She'll be the first item in the collection, or the seed value, and then call the lamb function, new operator, which happens to have another animal or something it's following as the parameter. And so the first animal will follow Mary, the second animal will follow the first animal, et cetera, up to 7 animals. So we do a list size of 8, which includes Mary, and then we trim off Mary and then keep the 7 animals at the ends, and we get 7 animals. That didn't show up. And then we get 7 animals following her around. So pretty straightforward. And now you guys know how to use the iterate method in the streams API. So let's look at filtering. Filtering is another really common operation in functional programming languages, and basically it works on a predicate expression. The predicate expression will take an object that is testing and then return a Boolean value for whether it passes or doesn't pass the filter. And then you can apply this to an expression like that one, adult equals attendees.filter, where the age is greater than Java 1.8. Okay, maybe my math is wrong on this one. What's the legal drinking age here in Europe? I think it's 16? Yeah? Okay, I think in the US we're 21, right? So this is completely wrong. All right, there must be some country where it's 18. So doing the filter expression, you can also apply this, and we're going to color the animals using a filter expression. So going through the stream and then getting a filter, doing a mod function on it, and then comparing it to 0, 1, 2, 3, and then applying different colors to it, yellow, cyan, and green, and then we can color the animals with a fairly succinct expression. So let's turn on filtering. Here's the rainbow code, pretty similar to what I showed you before. And this is kind of cute, the set color method. Anyone want to guess what JavaFX filter I'm using to accomplish this? This is a JavaFX geek time. Somebody must know what the filter name is. I'll give you a hint. It starts with color. Louder? Okay, I think somebody said it. Color adjust. So this is a really cool filter. You can modify the hue of an image. And so I'm basically coloring the animals by doing a little funky color math to modify the hue according to what color you passed in to try to get it kind of close to that color. And hopefully it works. Okay, so we've got animals. And voila. Now we have colored sheep, lambdas, things. And so if we go back to the barn, what should happen? What? Vanish? Oh, they should go back into the barn. Okay. That probably would be a good enhancement to like have them go home at night, but unfortunately, our silly algorithm just adds to the end of the list. And the way we coded it, if you remember, it pulls the last animal of the list and adds 7 more, so we should have 14 total. And then here you see, oh, no hit detection. Okay, so another enhancement we need to add. And let me color the sheep. All right, so that's a little bit about doing filtering. Now, there's also a bunch of convenience methods on collections you can use to do different operations like this. There's a nice remove if operation on collections, so you can remove based on a predicate expression. So this is a nice way of trimming down a list without actually going through and filtering the whole thing and then creating a new list. Replace all is another operation which is added to the collection class. And there's also a new observable collection.filtered. So observable collection.filtered is only on the JavaFX APIs, but it's quite handy to go and filter a whole collection without creating a stream and then going through that. So we're going to use those to create a church. And the idea with the church is that the folks, so we have all these animals and we need to, we can't send them home to the barn because we haven't implemented that. So we're going to find another way to cull them. And we'll do some humanitarian work, and we're gonna feed the homeless. So the folks in the church, they'll cook the animals. The only gotcha is they're a little bit picky. They refuse to cook any animals except for the white ones, the pure animals. So we've got a filter, a predicate expression, which checks the color of the animals first, and then we use it in both the filtered. On the JavaFX collection to get back a filtered set of animals and then check the size, and then we use it to remove the animals as well. So let's try the church and see how it works out. We should both see the number of animals decrease and also the number on the church go up. So what will the number in the church go up by? What we expect it to go up by? Anyone want to guess? All right, I heard 3. 2? Okay. Let's see. Yeah, so 2 white sheep and voila. Okay, so the number's 2, even though we can't see it quite yet. Come on. Go. All right. So we killed 2 sheep, and you can keep going in a loop here and trying to kill off all the sheep, but this takes a while. So later on we'll have to find a better way to kill off these sheep because they keep reproducing. Okay, so mapping. Map is another really useful stream operation. This takes a list of objects and converts it to another type of object. And you'll find that the more experienced you are with the stream APIs, the more complex map and chaining of maps and different map usages you'll find in your code. It's quite a handy operation, and once you get the hang of it, it lets you do lots of powerful things. So I'm going to use this to map whatever animals we have and turn them into eggs when you go to the chicken coop. So we're just going to magically egg-eyes all of the guys in the stream. And so you can see here I've done a little Lambda expression where I'm actually calling the constructor and passing in the following guy. So there's another way you can do this too, if you're a map guru. And I want your opinion on which one you like better. So this one uses a Lambda expression. This one uses two method references, a double map, and each map has a method reference rather than a full Lambda expression. So if you can grok this, basically what's happening is it's taking the stream of objects, it's converting it to a stream of what I'm following, and then it's taking the stream of what I'm following, and it's creating a new set of objects by passing that to the constructor. So it essentially is the same algorithm where we're passing in what we're following to the constructor, but rather than a Lambda expression where we put the methods in there, we've changed two maps and then passed the method references, and it's actually it'll have the same exact behavior. So what do you guys like? Show of hands. Who prefers Lambda, like the full Lambda syntax? Yeah? And who likes chaining maps? Okay. So the more people are comfortable with the first one. I think the first one, my feeling is it's slightly more readable in this case. But you can see how, like, if you really get the map operators, you start doing like really clever, tight things. And in more complex cases, you'd have a very long Lambda expression, which you could collapse into a couple maps. So this is a powerful way of using the APIs. So let's see if we can get some eggs out of our little factory here. All right, so now we've got the chicken coop, and so we'll grab some lambs and hop to the chicken coop, and voila, fresh eggs. Now you notice we have 3 eggs following us for every animal we've created. And so if these eggs hatched, how many chickens would you expect to have? All right, so 21. I heard somebody in the back say that. So that's good, but the problem, and this is a good way of describing the next operation, which is flatmap. Flatmap, I think, is one of the trickier new stream APIs to understand how it works. But if you can imagine, you've got a stream of stuff, in this case, a stream of eggs. And if you hatch the eggs, what you'd end up with is you'd end up with a stream where each stream element is a stream that contains 3 chickens. So you end up with a stream of streams. And so flatmap lets you collapse. It simultaneously maps and collapses the stream into a single stream. So rather than a stream of 7 streams of 3 chickens each, you get one single stream of 21 chickens would be the goal. So here's the basic syntax of flatmap. Basically, the flatmap takes a stream of objects, and then it goes to a stream of streams. For each object in the stream, you have to return another stream. And the list, as a result of that, the list can get longer or shorter, but usually it will get longer. It could even stay the same size. And this is how I'm using the flatmap to hatch the chickens. And the hatch function, I'll show you in just a sec, and that simply creates a stream, which flatmap is then going to, and here's why you never trust your IDE. One of the things you'll notice when you're hacking on a lot of the IDEs on early Lambda support is they don't quite get everything right, so they give you errors where it's actually correct or vice versa. So only trust the compiler, not the IDE. Okay, so here's the hatch method, and it's actually returning a stream of chickens, and it returns a stream of, well, it cuts off the first one, so it's actually 3 chickens getting returned as a stream, each properly following the previous guy using the iterate function again. So let's give that guy a try. All right, so lambs and eggs and chickens. Okay, so we got a lot of chickens. Now, my daughter's favorite game, she's 10 years old, and she likes to play around with this app when I'm not looking. She'll turn them back into eggs again. And then she'll go and hatch them. And pretty soon you get really. So is anyone wondering how high we can go before the performance starts suffering? So I think while this is not a very graphics-intensive application, I think this is a fairly good testament that JavaFX is not too bad, right? That's a whole lot of eggs. Now, I believe when we apply the filter, yeah, okay, we're still good. If you get enough objects on the screen at once and you apply a filter, the filter is actually more expensive than the image operations, so it'll slow down a little bit, but we're still okay. And now we got rid of some of them because we went to the barn. So you can see that now getting rid of all these colored eggs is going to take forever. This would be the worst Easter hunt in history. So we need a better way to cull the animals. So we're going to introduce, this is the last operation I'm going to show, and the kind of a common foundation of the Stream APIs is reduce. So this allows you to take a big list of objects and then reduce them down to a single value, which is quite useful. So in this case, I'm going to use reduce to figure out the sum of all the sizes of the animals. Each of the animals in the program has a size. I think lambs are bigger than chickens or whatever. And then this is used both as a meal size for how big the fox is going to grow, and also I later clear out the list of animals. Okay, so now we've got the fox. So what should we feed our fox today? Do we want to feed him lambs, eggs, or chickens? Lambs? Okay, lambs. We'll feed him colored lambs, though. Because those church people are too picky to eat these guys. So we'll give him something tastier. And yum, yum. Okay, so a very simple example. Shows you the Stream APIs kind of visually. And I think a good way of describing what you can do with the JavaFX APIs overall. Now, I'm going to briefly describe a little bit about JavaFX on Raspberry Pi, and then we're going to see if we can get the same application working on a Raspberry Pi device, and then we'll call it a day. Sound good? All right. So Java runs on a bunch of different devices. These are just some of the different places where you might find Java running. On the small side, it would probably be Java ME. Running on the device on the large side, you'd be more likely to find Java SE. Although now that we have Java SE embedded for ARM, you're seeing a lot more medium to small devices running Java and JavaFX. So it really broadens what you can do with the Java APIs, especially if you're a Java SE developer. The nice thing about Java SE on small devices is you can use all the same open source libraries. You could even run full application servers, Glassfish or JBoss or your favorite application server. And it lets you reuse the same skills and technologies you're familiar with on desktop or enterprise development in a portable form factor. I interviewed James Gosling in Hawaii a few weeks ago as part of my night hacking video series. You can see the video at nighthacking.com if you're interested. But he actually uses the Raspberry Pi for inside of their robotic aquatic robots. And he runs a full, I believe he's running Jetty as his application server. And he serves up web pages which you can interact with to give commands to the computer remotely. So it's a cool way of applying this technology on a device, and he's using, I believe, Java SE 7 embedded, although he'll be upgrading to 8 once we actually have an official release. So I'm going to mainly talk about the Raspberry Pi today. I happen to have one of them here, although this one's in a nice aluminum case, essentially a big heat sink. But it's a really affordable platform. It has an ARM 11 chip, 700 megahertz. Only 35 euros for the Model B, so it's fairly inexpensive. And originally it was developed for educational purposes, but it has some unique features which make it really good for doing embedded device testing. So, for example, it has a set of GPIO pins on the top left there in the diagram, and that lets you hook it up to physical devices, use things which communicate over buses, and hook up lights and sensors and other things. It also has USB. You could hook up a keyboard, mouse, other input devices. I have a touch screen I'll show you in a sec. An Ethernet jack for network. You can also hook up wireless modules for USB if you want to do wireless audio, video, HDMI, etc. And this is an example of an accelerometer hooked up to it. This is the MPU 9150, which is a 3-axis. It's an accelerometer, gyroscope, and a compass in one chip, and it integrates over I2C as the bus. So we're using the Pi4J libraries for this. If you're using Java ME embedded, there's a built-in device access API. I believe we're working on that for 8, but I'm not sure what the status of it is. But you can do this today using the Pi4J library. So for our Raspberry Pi gurus, what are these two slots on top of the Raspberry Pi, the 2 ribbon cable on top of the Raspberry Pi used for? Anyone want to guess? Okay, camera, I heard one. What's the second? Okay, yes, LCD screen. So the intent, the camera is actually released. That was released last March, so you can actually buy those. The intent was the second one was to be used for an LCD screen, although I don't think they've actually produced one which interfaces with it. But in the future, there's a possibility of them adding a touch screen LCD type device that would make use of the second port. In the meantime, what we've been using, and it's a nice, well, relatively inexpensive touch screen which interfaces with the Pi, is this screen from Chalkboard Electronics. And it works. They have either 10 or 7-inch form factors. I haven't seen the 7 inches yet because they were having some production issues. But we've tested it with JavaFX 8 for touch, and you can use touch events and integrate with it quite nicely. And if you snap a picture of that discount code, you can use that on the site and get 10% off. Although this is not necessarily a promotion of them in particular. I think Johan later on in our second session is going to also show another touch screen which works with the Raspberry Pi. Okay, so to set up your Pi, you install Linux, get your Java 8 ARM for EA. I've already done this on my Pi. And then you load up some JavaFX apps, and we know how to develop on the Pi. Okay, 2 gotchas. No WebView and no media. So the main reason for this was scheduling on the Java 8 release to make sure they had good performance and stability on these items. There's not an easy workaround for the lack of WebView other than just coding your application in JavaFX without accessing HTML. You could always launch links in a browser, but it's not quite as convenient. The media, there is a workaround for, though. So you can run a native media container and then have a transparent JavaFX window on top of it, so you could do menus and put stuff on top of the Raspberry Pi screen. So that you can work around. So let's see if we can get our project working on the Raspberry Pi. Okay, so I've got a Raspberry Pi. I'm not actually going to use a touch screen because it's impossible for the members in the audience to use it. So instead, we're going to use this screen capture device, which is not that much different than what the Parlays team uses to capture stuff for recording here. Power. Okay, and I'm actually going to power it directly off of my laptop USB. There we go. Blinky, blinky. All right, well, let me get out of the presentation and see why we're not blinking the way I want us to. And see why we're not blinking the way I want us to. Okay, so here is the Pi screen booting. Okay, I see I was waiting for the Ethernet lights to light up, so they just came on, so we have Ethernet access as well. So can you guys in the back see read the text on screen? Okay, so fortunately, we're only going to use this as a display for the graphics. For the actual device access, we're just going to hook up over SSH. So this is a little more readable in the back. Yeah. Okay. And this is a pro tip for anyone who has Macs. If you're trying to find your Pi on a network and you're not quite sure where it is, ARP-A will show you what's broadcasting. And I think it's the 212 guy. All right. So now we're on the Pi. Now I actually made build scripts so we can compile and run the actual project on the Pi. And just to prove that we're doing real stuff here, let's hack some code. We'll modify. Let's modify the that wolf was pretty boring. He just got bloated and fat when he ate things. But I think we need to put him on a diet. Okay, nest. Here's the fox. Okay, so you notice I have a scale X and scale Y here. We're gonna make these not quite the same. Let's make him thin. So now when he eats animals, he's no longer going to grow linearly. And I'm going to execute the build script and see if we can get this running on the Raspberry Pi. So one of the things you'll notice is compiling on the Raspberry Pi is not quite what you're used to from desktop computing. It's quite a bit slower. You can actually compile on desktop and you can copy the class files or jar files directly to the Raspberry Pi, which I think is a better workflow in general. But make sure you have exactly the same, especially if you're doing early access builds like we're playing around with, make sure you have exactly the same early access builds on both sides. Otherwise, you can have incompatibilities between what you're developing and what you're deploying to the Pi. But you can also compile directly on the Raspberry Pi, and it takes a little bit longer, but gives you consistent Java runtime across the two devices. So it'll show up here. This is the console output, and this is the actual visual display for the game. And I have a keyboard here. This is another cute device. If you have a Raspberry Pi and you use it for what I hear is the most common use in Europe as a media player, having a small keyboard like this to kick back on the couch is quite handy to use with your Pi. Okay, so we got it working. Oh, lambs. Now, the JavaFX performance is decent. I think they're still doing some tuning on it, but it's not horrible. But you'll notice every time I go to one of these objects and it goes through a loop of constructing objects and stuff, it's a little bit jerky. So one of the things I noticed is, in general, like the graphics performance is reasonable, but anything you do on the CPU, so the graphics is all hardware accelerated, but the CPU is fairly slow. It's like using like an old Pentium 4 or something equivalent to that. So not exactly the best CPU. About a quarter of the power of your like iPhone or average media device. But it's actually playable on the Pi, and the graphics all works just like on desktop. I didn't have to modify the program to get it to work on the Pi, and bam, tall fox. Tall fox. All right. So in a nutshell, you can develop stuff on the Raspberry Pi fairly easily. Reuse your JavaFX knowledge, and even take advantage of Lambdas. We are running the latest Lambdas code on the Raspberry Pi. So With that, I'd like to conclude the session, and thank you very much for attending the workshop that Jim, Michelle, and I gave on JavaFX 8 features. So enjoy the rest of your day.